Welcome to this new chapter. My name is Luz Mendes. Before starting to build, it is essential to carry out the preliminary activities. These include land clearing, tracing, and leveling to ensure the sea is ready to receive the structures. Soil is another key factor in construction, as it determines the type of foundation needed. Here are the most common types. Sandy soils. These are loose soils with good drainage, but they lack strength. Deep or reinforced foundations are needed in these cases. Clay soils. These are the most cohesive soils that can retain water, making them expensive and challenging. Their load-bearing capacity is low and requires detailed studies and special foundations. Rocky soils. They offer excellent loading bearing capacity and stability, making them ideal for large constructions. However, excavation is more expensive and slower. Silty soils. These soils have very fine particles and behave unpredictably, especially when wet. Therefore, it is important to conduct geotechnical studies before building on them. The first step in any construction project is land clearing. This stage is crucial to prepare the area where the structure will be built. Let's see what this process involves. Removal of vegetation and debris. It is common for the land to have vegetation, stones, or debris that must be removed to leave the area obstacle-free. Machinery, like black holes, make these work easier on larger sites. Preliminary leveling. In some cases, a basic level of the land is needed before layout. These help reduce extreme unevenness and allows for more precise work in the following phases. Removal of contaminants of the land has been previously used. It is important to ensure that there are no contaminants such as industrial waste or toxic materials. These not only ensure safer construction but also the well-being of those working on the site. Once the land is cleared, we move on to the layout and leveling, two fundamental processes to ensure that the construction is properly aligned and positioned according to the architectural plan. Land layout. These involves marketing the boundaries and locations of construction elements, such as walls and columns, directly on the ground. Tools like measuring tapes, stakes, and strings are used to mark the exact dimensions of the structure. This step must be done with the precision to avoid issues with the placement of structural elements. Use of theodolites and laser levels to ensure that the marked lines are perfectly horizontal and aligned. Theodolites and laser levels are used. These tools allow precise alignment of stakes and strings, avoiding unwanted slopes. Level control. The level processes ensure that the working surface is at the correct height. This step is essential for the stability of the foundation. Height differences between various points on the land are measured and adjusted to achieve a uniform level. Verification. Once the layout is complete, all measurements are checked against the architectural plan to ensure that there are no errors in dimensions or alignments. And before delving into construction processes, it's important to know a bit about the following topics. We begin with the concrete strength, one of the most important factors in structural design. What is concrete strength? Concrete strength refers to the ability of withstand loads without breaking. It is measured in megapascals or kilograms per square centimeters and vary based on the mix and type of cement used. Compressive strength. This type of the most common type is a compressive strength, which is the ability of concrete to withstand loads that press on it. This strength is usually tested at 7, 14, and 28 days after pouring, with a standard value at the 28 days that can range from 100 to 500 kilograms centimeters square, depending on the intended use. Concrete curing. To reach its maximum strength, concrete must be properly cured, which involves keeping it moist for an extended period. This prevents the concrete from cracking and losing the strength. There are different types of concrete, each designed to meet specific needs of a construction project. Thin concrete. This type of concrete does not include reinforcement and is used in elements that do not bear heavy loads, such as sidewalks or slabs. Its strength is lower compared to the other types. Reinforced concrete, the most commonly used in large structures, like columns, beams, and slabs. This concrete is reinforced with steel bars to increase its ability to withstand both compressive and tensile stresses. Ready mixed concrete. This concrete is prepared in a plant and transported by trucks to the site. Its main advantage is the consistency and the quality of the mix, as it follows precise proportions of water, cement, and aggregates. Self-compacting concrete, a special type of concrete that, as its name suggests, compacts on its own. It does not require vibration to settle, making it ideal for complex structures or hard to reach spaces. High strength concrete, used in structures that need to bear very heavy loads, such as skyscrapers or bridges. This concrete has a strength exceeding 400 kilograms meter centimeter square. Now let's talk about rebar, an indispensable material for reinforcing concrete. Function of rebar. Steel rebar is used for reinforced concrete in structures like columns, beams, and slabs. Concrete is very strong in compression, but weak in tension. But this is where rebar plays a crucial role as it absorbs tensile forces. Types of rebars. Rebars classified based on diameters and their strength. Each type is used for different applications, depending on the loads that the structure needs to bear. Proper placement. It is essential that rebars are placed with their proper concrete cover to prevent corrosion and ensure their structural capacity. Armex is a prefabricated reinforcement material used to speed up the construction process and ensure the proper steel distribution in structural elements. What is Armex? It is a set of pre-assembled rebar that forms frames or reinforcement structures for columns and beams. By being pre-assembled, it simplifies the construction process and reduces errors in the placement of reinforcements. Common uses. Armex is mainly used in columns, beams, and footings, where its pre-designed shape endures a strong and consistent structure. It saves time and labor compared to manual webboard assembly. Now let's move on to the construction process. Foundation. With the land laid out and leveled, the next step is foundation excavation. This is one of the most delicate processes as it defines the depth and type of foundation that will support the entire structure. Types of excavations. Excavations vary depending on the type of foundation being built. They can be shallow for small houses or deep for larger structures or difficult terrains. Use of machinery. Most excavations are done with backhoes, although in smaller plots or hard to access areas. Manual excavations may be necessary. Excavation depth. The depth of the trenches depends on the type of soil and the load the foundation will support. A geotechnical study will determine how deep these trenches need to be. Trench cleaning. Once the excavation is complete, the trenches must be cleared of debris or loose material to ensure good adhesion with the foundation. This is important to prevent uneven settlements in the future. The foundation base is a thin layer of concrete placed at the bottom of the excavated trenches before starting the foundation construction. Its purpose is to provide a uniform and clean base on which the foundation will be built. Materials used. The base is made of a simple concrete mix without reinforcement, with a suitable water cement ratio to ensure its strength and fluidity. Low strength concrete is used since it does not bear significant loads. Placement of the base. A concrete layer approximately 5 to 10 centimeters thick is poured at the bottom of the trenches. This creates a flat surface and prevents soil moisture from affecting the foundation. Functions of the base. Besides leveling the base protects the reinforcing steel that will be placed later, preventing direct contact with the soil. It also reduces the likelihood of deformations in the foundation due to the contact with the natural ground. We begin with the local stone foundation, a traditional option in areas where this material is abundant and cost effective. The type of foundation is mainly used in low rise buildings and stable soils. Characteristics of the local stone. It is a natural, irregular, and high strength stone. Placement is done manually, arranging the stones so that they will fit well with each other, avoiding large gaps. Construction process. The stone is placed into a mixture of concrete or mortar and previously excavated trenches. This provides a strong and durable base, especially for small houses or structures that do not require deep foundation. Advantages. It is an economical option that can be quickly executed in rural areas. Additionally, the stone is highly resistant to compression, ensuring good load bearing capacity. The isolated footing is a foundation used when the loads from pillars or columns are independent of each other. It consists of a reinforced concrete base that distributes the weight of a column onto the ground. Use and characteristics. Isolated footings are common in buildings where columns are distributed separately, such as low and mid-rise buildings. The size of the footing depends on the load it will bear and the soil strength. Construction process. First, the ground is excavated and a steel grid is placed at the bottom of the trench. Then concrete is poured over the reinforcement, forming the footing. Advantages. It is efficient in terms of materials and costs, and it works well on firm soils where the loads are not excessive. The continuous footing is another commonly used type of foundation, especially for structures with continuous load bearing walls. Unlike isolated footings, the construction weight is distributed continuously along the ground. Use and characteristics. Continuous footings are ideal for buildings with bearing walls, like traditional houses. They are also used on low strength soils where it is necessary to distribute the load more widely. Con- Construction. Similar to the isolated footing, but instead of forming a square or rectangular base for a column, the footing extends along the wall it will support. Steel reinforcement is placed in the trench and concrete is poured to create a solid and continuous base. Advantages. It distributes loads more evenly, making it suitable for less compact soils. It is also easy to construct and allows for continuous weight distribution. The raft foundation is one of the most robust options for large constructions or terrains with low load bearing capacity. Instead of supporting loads at specific points like footings, the raft distributes the building's weight over the entire surface on the ground. Use and characteristics. It is used in tall buildings or on low strength soils where the traditional foundations are not sufficient. It is essentially a reinforced concrete slab that covers the entire seat of the structure. Construction process. First, a layer of lean concrete or a base layer is placed, followed by a steel mesh across the entire surface. Then a thick layer of concrete is poured, creating a rigid and strong slab. Advantages. It distributes loads evenly, making it suitable for challenging terrains or buildings with high structural demands. However, it is more expensive and require a larger quantity of materials. Pedestals are small but crucial structural elements in foundations. They are used to transfer the loads from columns or pillars to the foundation, whether it is an isolated or continuous footing. Use and characteristics. Pedestals are reinforced concrete blocks placed directly below pillars. They are smaller than footings, but their role is to efficiently connect the transfer load to the base of the foundation. Constructions. Like footings, pedestals require steel reinforcement inside to ensure their strength. They are placed directly beneath the columns and connected to the existing foundation. Advantages. They are ideal for local reinforcements in columns or areas where loads are concentrated. Although they do not support large areas like footings, they are key for the stability of individual columns. Thank you for watching. See you next time.